of Geodesy as you've already outlined. And I think you've got a great vision for what can come forward out of this. Thank you.
Hello, I'm Patrick Cunningham. I'm president of Blue Marble Geographics. I have a few slides, but I guess I'll just stay here in this nice comfy chair. If you're familiar with Blue Marble, we've actually been working on a lot of these challenges that Juliana just mentioned, and that Kevin's ideas are bringing up, over the course of the past 15 years. And it's that bringing into software the ability to work with highly accurate mapping data and helping software users kind of bridge that gap from the survey geodetic data to the GIS area. And so we're very excited to be a part of the conversation, to contribute some ideas on this. And so Kevin asked us to kind of pick a topic to talk about, I guess, or he left it pretty open. So I said I would talk about HTTP. So it's a nice new acronym to throw around for y'all. How many people are familiar with HTTP? How many of you work for NGS? So HTTP it's a time machine for surveyors, I guess. It's horizontal time-dependent coordinate system, so coordinate reference frames, and it's something that NGS has worked on for a while, and we're actually implementing in our software right now. I'm not trying to be a vendor here, but just that challenge of addressing that highly accurate mapping concept is something that we're able to bring to ESRI users through our extensions into ArcMap and such. And it's been interesting, and it's addressing the issues of the fact that the Earth's crust is moving, moves at different times, and that GPS accuracy is improving, increasing, and all these issues that Brent and other speakers have been talking about over the past couple of days. So it's really kind of, for our audience, it's very interesting. I'm not sure how interesting it is to the broader audience, but for people that care about highly accurate mapping, it certainly is. And I guess I would just say that for any model to address it properly, the change that GIS needs to make is probably from one of handling there's a lot of things that to talk about, but that's one of those points I just wanted to
All right, thank you. I equivocated endlessly about whether I'd use slides or not, and I think I'm going to go ahead and stand up there and do that, right? All right. I'll try to make it brief. I only have 25 minutes, right? Is that? All right, I'll talk fast.
We can hold Mark.
Well, I think I got this thing here. I think does this work? Sounds like it works. So, what am I going to do here? Okay, gotcha. Yeah, Kevin sent out a pretty extensive list of questions for us to answer, and he said, just answer one. I answered all of them. And I have a real hard time reining myself in. I get real excited about Geodesy, but I'm going to try to be more practical right now, which is real hard for me. I'm going to try. Well, when I think of a GIS, I just threw that in there, actually, GIS geodetic data model. I am being more generic about this. What does that make me think of? Or what would be useful to me in how I do my business, how I see other people do their business. It needs to be standardized, and Kevin already talked about some of this stuff, so I'm going to make it kind of quick. It needs to be widely accepted for storing data and the relationships between those data. That's extremely important. And it should be a tool for performing geodetic analyses as well. And we can get into what that means. I'm trying to stay kind of general right now. And if it was a convenient platform for building applications, that would be great too. You know, something you could actually build something on fairly easily to leverage that geodetic data, or those geodetic data. And I have this thing on here for facilitate use and integration of accurate data. Now that's a big deal to me, and there's been a lot of talk at this summit about accuracy. You know, 10 centimeters on your cell phone. All right. Then we can talk about what's the difference between accuracy and precision and all that. What do people really mean by that? And the devil's in the details, as everyone's been saying. It's a big deal. That's going to be a tough one to get to. And it's not so much the device. It's the data that underlies it, as Jan was talking about earlier. And another big thing for me is giving us a way to visualize geodetic data. I think that's a really powerful thing for understanding the data and communicating those concepts to other people. And there's an educational role to be played here. So what I'm going to do real quick is I'm going to go through some visual slides to keep things for that side of it, but also they'll touch on some of these other issues that I have on my little list here as well. And just because I bring it up here doesn't mean I necessarily want that it should be a topic of conversation, but it's more how I see something like a geodetic data model being used. And that should work, right? Hitting the space bar to make that thing advance. How about that? Oh, yeah, I got to start it first, man. It's not that easy being up here. You know, I've never done this before. All right. Now, here we go. This is the whole WGS84 bugaboo that I get all bent out of shape about. And this is a map showing the horizontal difference in feet between NAD 83 and WGS84, whatever those two things mean. All that has to be defined at a particular time, 1997.0. It's January 1st, 1997. So you all are looking at that, right? You're not looking at me. I'm going to hit the button here, and you'll see that it changes with time, in 5 years and then in 10 years. Again, because it's just kind of fun, you know. So when we're talking about 10 centimeter accuracy, and we want to do a datum transformation from NAD 83 to WGS84 and say, oh, that's no problem, it's in the software. Well, what does that mean? Very careful about that stuff. There's a lot going on here. Another thing that came up is being able to, God, this came up a lot, getting accurate survey data into a GIS. And I better start talking faster because I'm going to take too long. But one thing is surveyors often use localized coordinate systems because they want their distances on the map to equal what they measure on the ground. Well, here's an area, Maricopa County, Arizona, at least 10,000 square mile area on the map here, more than that. I want to maybe I could use GIS or a geodetic data model to design a low distortion projection for that area, and that what you're seeing on the map there is using geodetic data to analyze that so you can see what the distortion actually is. And the green is good on the map. Green is 1/10 of a foot per half mile linear distortion. So there's another potential tool. And you can't, in my mind, talk about geodesy without somehow touching on gravity. And I'd love to go into it in a lot more detail, but I can't. But here's a map of geoid slope, or geoid gradient, the change in geoid height horizontally in Alaska. And there's a lot of variation there. There's things we can do about it. But another thing that's interesting about this is, what's the change in geoid slope from one geoid model to the next? That's a little more interesting and maybe even a little more disturbing, if I might say so. So another way to analyze the data. And that's all I have.
Well, I hope you don't mind a little drama this morning. Well, this afternoon now. I'm going to tell you about a problem that's affecting everybody in the world. This is a brand new problem we've never seen before. And it really leads us into a kind of a treasure hunt. So I'm going to go forward here. On February 10th of 2009 of this year, two satellites collided. This is the first time this event has ever happened in human history. An Iridium 33 and a dead Russian Cosmos satellite collided over Russia. Here I've got some video.